2 billion tires every single year. And almost nobody knows what actually goes into making one. Inside a single car tire, you'll find up to 200 different raw materials, 25 separate components, and 12 distinct rubber compounds, all packed into something that weighs about 20 pounds. Today we're going inside the factory to see exactly how it's done. We're heading into the modern tire factory to see how these incredible feats of engineering come together. From raw rubber to the finished radial tire that keeps you safe on the road at 70 miles per hour. Behind every single one of those tires sits a manufacturing process that blends 19th century chemistry with 21st century artificial intelligence. It's one of the most fascinating production stories in all of manufacturing, and it starts way further back in history than you might think. So let's rewind way back. The story of the modern tire really begins in 1839 with a man named Charles Goodyear. Goodyear was an American self-taught chemist who'd been obsessed for years with trying to make natural rubber actually useful. Raw rubber had a huge problem. In cold weather, it became brittle and cracked. In hot weather, it turned into a sticky, melting mess. Nobody could figure out how to stabilize it. Then one day in 1839, while experimenting with mixing rubber and sulfur, Goodyear accidentally dropped the mixture into a hot frying pan. To his absolute astonishment, instead of melting further or vaporizing, the rubber stayed firm. As he cranked up the heat, it got harder. He had stumbled onto something revolutionary. By 1844, he'd perfected the process enough to receive U.S. patent number 3633. He called it vulcanization, and it changed everything. Vulcanized rubber was pliable, waterproof, moldable, and durable. It became the foundation the entire tire industry would be built on. Tragically, Goodyear himself never profited from his discovery. He died in 1860 while traveling to see his dying daughter, only to learn upon arriving in New York that she had already passed. He collapsed and died at the Fifth Avenue Hotel at the age of 59, leaving behind nearly $200,000 in debt. It wasn't until 1898, almost 4 decades after his death, that Frank Seiberling founded the Goodyear Tire and Rubber Company in Akron, Ohio, and named it in his honor. Akron would go on to become the rubber capital of the world, home to multiple major tire manufacturers. But vulcanization was only half the equation. You also needed the pneumatic tire, the air-filled tire, and that story has its own unlikely hero. In 1887, a Scottish veterinarian named John Boyd Dunlop was watching his 9-year-old son Johnny struggle on a tricycle fitted with solid rubber wheels. So Dunlop, being a practical man, grabbed a big wooden disc, formed a tube out of sheet rubber, and inserted a one-way valve and inflated it with air until it could support his son's weight. He actually made the tubes from pieces of an old garden hose, bonded them together with liquid rubber, and fitted them around each wheel. It worked brilliantly. By December 1888, Dunlop had a patent, and by 1889, the Dunlop Rubber Company was founded. That same year, on the other side of the English Channel, the Michelin brothers founded their company in France. Now, a quick footnote, Dunlop wasn't technically first. A Scottish engineer named Robert William Thomson had actually patented a pneumatic tire back in 1845, but Thomson's version was too expensive to catch on, and the idea was basically forgotten for over 40 years until Dunlop reinvented it independently. From there, innovation came fast. In 1903, P.W. Litchfield at Goodyear patented the first tubeless tire, though it wouldn't be used commercially until the 1954 Packard. In 1908, Frank Seiberling introduced groove tires for better traction. In 1910, B.F. Goodrich discovered that adding carbon black to rubber produced a 10-fold increase in wear resistance, a discovery that literally gave tires their distinctive black color to this day. Carbon black still makes up 25 to 30% of the rubber composition in a modern tire. Then, in 1934, Michelin introduced steel reinforcement. In 1936, a Finnish company that would become Nokian created the first winter tires, called Hakkapeliitta. In 1937, B.F. Goodrich produced the first synthetic rubber tires. And in 1946, Michelin patented the radial tire, which replaced the older bias ply tire design and became the architecture that essentially every car on the road uses today. The radial tires, crisscrossing, steel belts, and perpendicular body ply construction revolutionized how tires handled heat and wear. All of that history, all of those breakthroughs, they're baked into the DNA of every tire rolling off a factory line right now. And today, there are roughly 455 tire factories operating worldwide, producing over 2 billion tires a year in an industry valued at nearly $143 billion as of 2024. That number is expected to climb to over $211 billion by 2032. So with that context, let's walk through how a modern tire actually gets made step by step. It all starts with the raw materials, and there are a lot of them. The recipe for a tire involves natural rubber, synthetic rubber, carbon black, silica compounds, special oils, pigments, antioxidants, and a whole list of chemical additives. About 60% of the rubber used in the tire industry is synthetic, derived from petroleum-based hydrocarbons. The remaining 40% is natural rubber, harvested from rubber trees. A typical passenger tire contains about 20% natural rubber by weight, and the rubber compounds in total make up over 80% of the tire's overall weight. Now here's where silica compounds come in as a game changer. In 1992, Michelin introduced what they called the green tire technology, replacing much of the carbon black with silica compounds. This innovation dramatically reduced rolling resistance, improving fuel efficiency by up to 5% while maintaining grip. Today, silica-enhanced compounds are standard in most passenger tires, representing one of the biggest advances in tire chemistry since vulcanization itself. All of these raw materials arrive at the factory in bulk. Bales of natural and synthetic rubber are sectioned, cut into portions, and weighed with extreme precision. Step 2 is mixing. This is where a massive machine called a Banbury mixer takes center stage. Think of it like an industrial-scale food processor, but for rubber. The Banbury mixer combines the various raw materials for each compound, blending them at around 250 degrees Fahrenheit, or about 120 degrees Celsius, into a homogenized batch of black material with the consistency of gum. This entire process is computer-controlled to ensure absolute uniformity. Remember, a modern tire uses up to 12 different rubber compounds. Each one is mixed according to its own precise recipe because the rubber on the tread needs to behave very differently from the rubber on the sidewall or the inner liner. Step 3 is where those rubber compounds get shaped into actual components. The mixed rubber is fed into an extruder, which is basically a high-pressure screw system. The rubber goes in, gets heated, blended further, and pressurized, then flows through the extruder head, where it's shaped under pressure into specific profiles. Some rubber is also calendared, meaning it's pressed into thin sheets or impregnated into fabric or steel cords to create reinforced composite materials. This is where you start to see the individual pieces that will become a tire. The inner liner, a special rubber compound designed to resist air and moisture, takes the place of the old-fashioned inner tube. Then there are the body plies, typically made from polyester cords coated in rubber, which give the tire its structural strength. The steel belts, rubber-coated sheets reinforced with steel wire, provide rigidity and help the tread maintain contact with the road. And there's the bead assembly, which includes not just the steel bead wire, but also the bead filler or apex, a triangular rubber component that helps transfer forces between the rim and the tire body. Now here's where it gets really interesting. Step 4 is tire building or assembly. And this is where all those components come together on a machine called a tire building drum. And this is the part of the process that might genuinely surprise you. Catherine Hankook, a director at Rockwell Automation, who works specifically with the tire industry, put it bluntly. You would be shocked at how non-automated some of it still is. And she's right. In many factories, you'll see a cutting-edge VMI tire building machine, one of the most advanced pieces of equipment in the world, sitting right next to a manual station where a skilled worker is wrapping rubber by hand and cutting it with a hot knife, both in the same building. The tire industry is, in many ways, a legacy industry. Some of these plants were built 100 years ago, and the average age of the workforce in some facilities pushes 60. But whether it's done by hand or by machine, the sequence is the same. The inner liner goes on the drum first, then the body plies, then the beads, which are rigid hoops of steel wire coated in rubber that anchor the tire to the wheel rim. The assembly gets turned up over the beads, then the steel belts are applied, and finally the tread. Once all the components are assembled, you've got what the industry calls a green tire. Not green as in the color, green as in unfinished. It looks roughly like a tire at this point, but it's soft, pliable, and it has no tread pattern. It's not yet a tire in any functional sense. That changes in step 5, which is arguably the most important stage of the entire process. Vulcanization, also called curing. This is where Charles Goodyear's 1839 discovery comes full circle. The green tire is placed inside a mold, and that mold is the negative impression of the finished tire, complete with the tread pattern, sidewall lettering, and all the other surface details. Then the mold closes, and heat and pressure are applied. Steam is pumped in to heat the mold to over 300 degrees Fahrenheit, roughly 150 degrees Celsius. Some factories run even hotter, with superheated water controlled at 170 to 180 degrees Celsius and internal pressures maintained at 2.2 to 2.6 megapascals. For a passenger car tire, this curing process takes about 12 to 15 minutes. During that time, the sulfur in the rubber compounds creates chemical crosslinks between the polymer chains, transforming the soft, sticky green tire into a firm, elastic, durable, finished product. The rubber literally changes at a molecular level. It becomes something new. And this step is no small deal for the factory either. The vulcanization process consumes about 60% of the total energy used in tire production. It's the most energy-intensive single stage by far. For larger tires, like off-road or heavy equipment tires, curing can take up to an entire day. Finally, step 6, quality control. And tire companies don't mess around here. Every single tire is inspected. Random samples are pulled for additional testing. Tires are X-rayed to examine the internal structure, checking for things like uneven steel distribution, broken cords, air bubbles, bad splices, or foreign materials. Some tires are literally cut apart and examined. Others are mounted on test wheels or road tested to evaluate handling, mileage, and traction. Michelin, for example, claims to conduct over 1 billion miles of tire testing per year. That's the equivalent of driving around the planet 40,000 times annually. Custom designing a new tire for a particular vehicle typically takes many months of testing, inspection, and quality checks by both the tire maker and the vehicle manufacturer before a single tire reaches a consumer. Now let's talk about where this industry is heading, because the changes happening right now are enormous. On the automation front, artificial intelligence is transforming tire factories. Michelin currently has over 200 active AI use cases across its business. They've developed AI-augmented inspection machines they call Iris that partially automate the detection of manufacturing defects, improving both efficiency and accuracy. Predictive maintenance algorithms are helping factories anticipate equipment failures before they happen. And smart automation, combined with learning algorithms, is pushing the industry toward what's being called Industry 4.0. But as Hankook noted, fully lights-out automation is possible, yes. None of these things are problems that cannot be solved. But are we there now in tire manufacturing? Not yet. Sustainability is the other massive trend, and here the numbers are moving fast. Michelin increased its use of renewable or recycled materials to 31% across its tires in 2024. Continental averaged 26% and plans to reach at least 40% within 5 years. In January 2024, Toyo Tire unveiled a tire made from 90% sustainable materials. Nokian went even further and opened the world's first zero CO2 emission tire factory in Oradea, Romania, producing its first tire on July 1st, 2024. As Continental's Dr. Matthias Haufe put it, "We are not reinventing the wheel, but we are reinventing the tire with more sustainable materials and more environmentally compatible production processes." And then there's smart tire technology. Bridgestone invested $550 million to expand a Tennessee plant specifically to equip all tires produced there with RFID tags. These tiny chips, embedded right inside the tire, store data like tire make, size, and type, and can be read even when the tag is completely hidden from view. It's a technology that ties directly into fleet management, automated logistics, tire pressure monitoring systems, and the broader trend toward connected vehicles. Meanwhile, the investment in new factories continues at a staggering pace. Yokohama is building a $380 million plant in Mexico. ZC Rubber is investing $550 million in another Mexican facility just 150 miles from the U.S. border. Hankook is pouring $1.6 billion into doubling production at its Tennessee plant to 11 million tires per year. The scale of all of this is genuinely hard to wrap your head around. China alone produces an estimated 600 million tires a year. The United States sells over 300 million tires annually. The top two companies, Michelin and Bridgestone, control roughly 15% of the global market each. And yet, when you look at a tire mounted on your car, it just looks like a black rubber donut. Simple, ordinary, maybe even boring. But now you know better. You know that inside that tire is the legacy of a man who dropped rubber into a frying pan in 1839. The ingenuity of a veterinarian who cut up a garden hose to help his son ride a tricycle. The precision of 12 different rubber compounds, each mixed to an exact recipe. The force of 300-degree molds pressing tread patterns into vulcanized rubber. And increasingly, the intelligence of artificial intelligence systems inspecting every square inch for defects the human eye might miss. 200 materials, 25 components, billions of tires. One of the most sophisticated manufacturing processes on the planet, hiding in plain sight on every road you've ever driven. The next time you glance at your tires, maybe give them a little nod. They've earned it. Now you know exactly how much goes into making a tire. So the next time you walk into a tire shop, you might want to know what happens to your money on the other side of that counter. Because in the next video, we're pulling back the curtain on the tire shop scam nobody talks about, and the real profit margins will genuinely surprise you.